Okay, good morning students. Now we are continuing. Okay, now you are given two curves. Y is equal to mod x minus 1 and y equal to 3 minus x. Then we have defined the curves. The curves are traced as we are taking the tracement. So draw the figure. Y is equal to minus of x plus 1. Y is equal to 1 minus x. So this curve is minus 1 to 1. Minus 1 to 2. Here 1, here 2. One minus x. Next. Second curve, minus 3 to 2, 3 plus x. Second curve, minus 3 to 1. Next, here 2, here 3. Next, 3 to 4 into 2, 3. This is also 2. Here 2, here 3. Y is equal to 3 minus x. Fourth curve, 1 to 2. Y is equal to x minus 1. Now what is the boundary region you see here? This is one line, and up here, and this is another line. Therefore, bounded region is, this is the bounded region, right? The rectangle. As bounded region is the rectangular area with axis you name it as O, A, B, C, D, A. With the area with A, B, C, D, A. How we get this area? So this area, so this you name it as that is equal to E, and then this area will be taken as this limits and these two you have to subtract. Okay, so this minus this you have to subtract. This is F. Okay. Therefore, A is equal to A1 plus A2. This is A1. This is A2. So A1 is equal to, we'll get area between AFODA minus AFOEA. A1 is equal to area of AFODA minus area of AFOEA. See here, AFODA minus AFOEA. This is the area. Okay, right? Now that is equal to, this area means this is the line and this is the line. So integral area under curve y is equal to 3 plus x minus area under curve y is equal to 1 minus x in limits minus 1 to 0. Like this. Now this part you have to see. Understood? Okay. Now what you can see here is now right now you can see here this area. I think you are clear with this part. Now I'll change this over. Therefore, A1 is equal to integral minus 1 to 1, minus 1 to 0. Minus 1 to 0, this area minus this area. Then you will get this area. Minus 1 to 0. This is 3 plus x. 3 plus x dx minus integral minus 1 to 0. This area. 1 minus x dx. That is equal to 3x plus x square by 2 minus 1 to 0 minus x square by 2 minus 1 to 0. So 2x plus x square minus 1 to 0. So 2 into 0 plus 0 square minus of 2 into minus 1. Okay. Plus minus 1 whole square. That is equal to 0 plus 2 minus 2. Have we got it here? Minus 8. Is 2 into here minus 1 plus 1. It is equal to 3 square units. Right? Now, next case, A2 we have to find. Are you clear? Not done up to here. A2 we have to find. A2 how will find? This is A2. Or A2 means it is the area region by enclosed by this curve minus this curve between these two limits. Between 0 to, what you can say? 0 to this curve minus this area plus this area. This you have to subtract both. Okay? So this part you have to be very careful. These two you have to subtract from this area. Okay? From this trapezium. So 0 to 1 triangle area and 1 to 2 another line you have to take. Not done up to here. Still we will continue. So there are two areas, A1 and A2. Both areas together will form this rectangle. Curves are traced and then you have found the regions. And these areas you have to find like this. This area we got triangle trapezium minus this trapezium. This is one trapezium minus this trapezium. But in this case, this trapezium consists of two triangles. So both you have to subtract from this line, from this boundaries. Okay? Not done. We'll continue second part. A1 plus A2 you will get finally total area bounded by the given two modulus curves. Okay, right? Next question. A2 I'll take now. Continuation. A2 is equal to area under curve. Okay, under curve y is equal to 3 minus x and difference of sum of areas under curve with limits 0 to 2. Okay, comma, and difference of sum of areas under curve 1 minus x with limits 0 to 1 and x minus 1 with the limits 1 to 2. This is what you are getting. This is 0 to 2, right? Now A2 how we find? Therefore A2 is equal to integral 0 to 2 3 minus x dx minus of this area. Again, this triangle you have to subtract. Okay, this triangle, what is this area? 1 minus x. Integral 0 to 1 minus x dx plus integral 1 to 2 x minus 1 dx. That is equal to 3x minus x square by 2 0 to 2 minus of x minus x square by 2 0 to 1 minus of x square by 2 minus x 1 to 2. So these two are taken separately. So now you can take here these values to be simplified. Okay, this triangle area under this curve between these two L's and this triangle under this curve between these two L's, and total this trapezium minus sum of these two will be this A2 will come. Okay, now clear? Now I will go to this part. Even order we got 3 units. A2 is equal to 3 into 2, 6 minus 0 minus of 6 minus 2 minus of 0, okay, minus of 1 minus 1 by 2, 1 minus 1 by 2 minus of 0 minus of 2 minus 2 minus of 1 by 2 minus 1. That is equal to 4 minus half minus of 0 plus minus half plus half minus half. That is equal to 3 square units. Therefore, area of the bounded region is equal to A1 plus A2, which is equal to 3 plus 3, that is equal to 6 square units. Now done. Understand, na? Like this you have to get. You have to carefully study the area of the region bounded between the two curves. Note down. We'll continue next question then. Okay, next. To the curves, next question, parts will go. These questions should be very much carefully attentive, and you have to be very keen in understanding the areas and then bounded trajectories. Okay, because any simple bounding limits or as area of the line will changes, na, then problem will come into wrong. So you have to be very careful in plotting the curves, sketching the curves, as well as identifying the region, identifying the boundaries, as well as locating the finding area with difference or sum of the given areas with the bounded lines. This is very important for you. Right? Next question. Prove the curves y squared to 4x and x squared to 4y. Prove that the curves divide the area of the square bounded by x is equal to 0, x is equal to 4 and y is equal to 4. Into 3 equal parts. This is what given. Okay. Now, first you have to trace the curves. X square equal to 4y, this is the curve. And y square is equal to 4x, this is the curve. Now x is equal to, solve it, y square is equal to 4x, x square is equal to 4y. On solving, what happens? So, x power 4 by 16 is equal to 4x, x power 4 minus 64x is equal to 0, x into x minus 64 is equal to 0, x is equal to 0 or x is equal to 4. So y is equal to 0 and y is equal to 4. So this is 0, 0, this is 4, 0, this is also 0, 4. Now there are 3 parts. This is one part, this is one part, this is one part. So A1, A2, A3. This is the bounding region. Okay. So this is O, A, B and C. Therefore, solution. By sketching the given curves with intersection point, Okay, we have got the bounded region as O, A, B, C, O, identified into three parts as A1, A2, A3. A1 is equal to, so something named as D and here E. Okay, A1 is equal to area of curve region ODBCO. A2 is equal to area of curved region OEBDO. Next, A3 is equal to area of curved region OABEO. Now we need to prove A1 is equal to A2 is equal to A3 by finding area of each region. Understand now? Okay, OABCO, it was divided into three parts. Now we have to find the three parts and we need to show they are equal. Okay, next. Therefore, A1 is equal to, we find A1 is equal to Y limits we take, right? Y limit because this is symmetric to Y curve. So Y limits under this curve and area under curve y squared 4x with limits 0 to 4 symmetric to y-axis. Because this curve we have to find. Okay, 0 to 4. So x dy what to take? Y square equal to 4x is the curve under this curve. Okay. So we find here this part. Therefore, A1 is equal to integral 0 to 4 x dy. X dy means y square 4x means y square by 4 dy, which is equal to 1 by 4 into y cube by 3, 0 to 4. 1 by 4 into 64 by 3 minus 0, which is equal to 16 by 3 square units. Next. Next comes A2 is equal to, this is A2, okay, or A3 will find first. A3 is equal to area under, okay, curve x square is equal to 4y with the limits 0 to 4 symmetric to x-axis. that is equal to x-axis means integral 0 to 4 x square by 4 dx 1 by 4 into x cube by 3 0 to 4 which is equal to 1 by 4 into 64 by 3 minus 0 16 by 3 square units. Next. A2. Area under the curve y square is equal to 4x with the difference of area under curve x square is equal to x square equal to 4y x square is equal to 4y with the limits 0 to 4. That is equal to A2 is equal to integral 0 to 4 y square 4x means 2 root x dx minus integral 0 to 4 x square equal to 4y means x square by 4 dx. That is equal to 2 into x power 3 by 2 into 2 by 3 0 to 4 minus 1 by 4 into x cube by 3 0 to 4. That is equal to 4 by 3 into 8 minus 0 minus 1 by 4 into 64 by 3 minus 0. 8 32 by 3 minus 16 by 3 which is equal to 16 by 3 square units. Hence, it was proved that A1 is equal to A2 is equal to A3. Three parts are equal, like this it was taken. Okay, that way. So the three parts is 16 by 3, this is also 16 by 3 and this is also 16 by 3. You got all the three parts as equal in area. Very clear? Bounded by that two curves, x square equal to 4y and y square is equal to 4x. You have to be careful in identifying the parts, regions with respect to which limits to be taken with respect to what axis, that all you have to be careful. Bus. Right? We'll do one more question. Okay, noted? Next question. right? Next. The figure shows the part of the curve y equal to 10 by x square. There is a figure already given here, right here. See here, 10 by x square, 1, 2, p. The figure shows the part of the curve y is equal to 10 by x square. Okay. Find the region A. It is A. Find the area of the region A. Also find the area for which region B and region C are equal in area. Find the area of region A. Also find B if area of region B is equal to area of region, right? Okay, I put area of region C. Okay, this is, you take it as given curve is solution y is equal to 10 by x square, where the feet of the perpendiculars are 1, 2, p divided into 3 regions. Okay, A, B, C respectively. Something you take it as Q. Okay, Q. 1 to PQ. Divided into 3 regions. Okay, so here therefore area of region A is equal to area under curve y is equal to 10 by x square in the limits 1 and 2. Therefore, A is equal to integral 1 to 2 10 by x square dx, which is equal to 10 into minus 1 by x 1 to 2. 10 into minus 1 by 2 minus of minus 1 by 1, which is equal to 10 into minus 1 by 2 plus 1, which is equal to 5 square units. Okay, first is 5 square units. Next, 2 to p, p to 5. Okay, this is 5. 1, 2, P, 5. Now, also given area is equal to area B, B is equal to area of region C. Therefore, integral 2 to P 10 by x square dx is equal to integral P to 5 10 by x square dx. This is equal to 10 into minus 1 by x 2 to P is equal to 10 into minus 1 by x P to 5, that is equal to minus 1 by P plus 1 by 2 is equal to minus 1 by 5 plus 1 by P. That implies 2 by P is equal to 1 by 5 plus 1 by 2, which is equal to 7 by 10. So P is equal to 20 by 7 square. P is equal to 20 by 7. Very nice. So that's the way P value will get. Okay? So this is very analytical type question, like these questions can come. Hence P is equal to, the value of P is equal to 22 by 7. Right? So note down this one. Note down. So three regions, these was found between the same curve and under. These two are equated and P value is found with respect to limits. This is very special type of question. Mostly it can come in the board also, because this is a somewhat twisted question. It's not a direct question. Are you clear? Yes? We'll do one more question. So this is very analytical. We'll go for next question. Suppose a function f of x is defined as a function f of x is defined as f of x is equal to 1 minus 2 sin square x. Find f of x. Also, it passes through the point pi of 1 by 2. Also, it passes through the point pi of 1 by 2. What is that? solution. So given f of x is equal to integral 1 minus 2 sin square x dx. Right? Next, this one. Find the, also draw the graph. One more question is there. Also draw the graph f of x and find the bounded region between ordinate x is equal to 0 and pi over 4. Now draw the graph. Right. 0, pi by 4, pi by 2. One by 2. And here also pi by 4. Pi by 2. F of x is equal to half 1 minus 2 cos 2x, integral given that is equal to integral cos 2x dx, which is equal to half sin 2x. So half sin 2x, this is the curve. Now what is asked between 0 to point pi by 4 comma 1 by 2, pi by 4 comma 1 by 2, right? Now what is the area? This is the area. A is the O, B, C, O. Therefore, as per plotting of curve, the area bounded by the curve half sin 2x between 0 to pi by 4 passing through pi by 4 comma the point 1 by 2 is A. So pi by 4 comma 1 by 2. Dash region O, B, C, O. Therefore, A is equal to integral 0 to pi by 4 half sin 2x. Okay, dx. That is equal to 1 by 2 into 1 by 2 into minus cos 2x 0 to pi by 4, which is equal to 1 by 4 into or minus 1 by 4 into cos pi by 2 minus cos 0, which is equal to minus 1 by 4 into 0 minus of minus 1, which is equal to 1 by 4 square units. This is the area. Okay, so at pi by 4 comma 1 by 2, this is the point. Okay, under this curve, put some x is equal to pi by 2, pi by 4, half into 2 into pi by 2. 2 into pi by 4 means half pi by 2, half 1. So automatically, if x is equal to pi by 4, y is equal to 1 by 2. So C is equal to pi by 4 comma 1 by 2. That is the intersection point. Automatically bounded edge OA BCO. OBCO. Right? No doubt. Sketched it and then area was drawn. No doubt. Very clear? So this is the area. Integral of sin to x, C won't be there because there are specific limits. Okay? 0 to pi by 4. C no need to mention because these are bounding limits, na? So C not a compulsory. Okay? Next month we'll go for one more question. Yes, we can go one more question. Big question, we'll go small question. Small question will go. So we'll do one more question. Okay, I think you are clear this part, right? The function of x is defined below. F of x is equal to modulus of 1, 1, 1, 1, 1 plus sin phi 1, 1 plus cos phi 1, 1. Evaluate the function of x and draw its graph. Find the bounded area between the curve f of x and ordinates x is equal to 0. Also find the bounded region between the curve of the curve y is equal to f of x with ordinates x is equal to 0 and x is equal to pi. Now we find this value first, f of x. Given curve is f of x is equal to 1, 1, 1, 1 plus sin phi 1, 1 plus cos phi 1, 1, which is equal to 1 into 1 plus sine phi minus 1 minus 1 into 1 minus 1 minus cos phi plus 1 into 1 minus of 1 plus sine phi plus cos phi plus sin phi cos phi. That is equal to 1 plus that is equal to sine phi minus of plus cos phi minus sine phi minus cos phi minus sine phi. Okay. Plus cos phi minus sine phi cos phi, which comes to be sine phi cos phi. Okay, leave this part. We get minus 2 sine phi cos phi. Okay, expanding it, which is equal to minus sine 2 phi. Again, minus sine 2 phi, you plot the curve. Okay, now this area, what you get here, 0 to pi, between 0 to pi. So you take this area, pi by 4. This is pi by 2. Therefore, area of the curve, area under the curve, minus sine 2 phi between ordinates x is equal to 0 and x is equal to pi is a is equal to, this is minus 1, okay, and this curve is 1. Zero to modulus of 0 to pi by 2, because this is negative side now. This is pi by 2. Is equal to OAB O is OAB O. Is pi by 2. So this is pi by 2 we take here. Zero to pi by 2 minus sine 2x dx, which is equal to half cos 2x 0 to pi by 2 modulus half into modulus of cos pi minus 1 minus 1, which is equal to 1 square unit, because modulus is there, right? So this is 0 to pi by 2. That is the area. So function is given, you have evaluated, and then we got it under the limits, right? So note down. So we can go for one, two, some more questions. Maybe within 1 or 2 days. Mostly we'll wind up this topic if possible. We can start the new session, that's the last session of the class in this week only. That takes maximum 15 days. So our deadline is able to easily complete it. You can complete exercise 8.2 also, NCERT. Okay. Complete exercise 8.1 and 2 and ask doubts if you have anything. NCERT. This bottle is over, I think. Sorry, sir. This is over ink. Okay. You have to get, I think.